Hello, our today's topic for the A-level chemistry 9701 is Hess's law. Hess's law is an important law in case of enthalpy changes. This law states that total enthalpy change in a chemical reaction remains the same. Either a reaction takes place in single or several steps. Either in single or several steps. For example, if we consider that A is a reactant and reactant A has to be converted into product D. Now, this A can be directly converted into D, and during this, the enthalpy change will be considered as delta H1. This is a direct route. Now, it might be A first change into B, and then B change into C, and then finally C change into the final product. Now, according to the Hess's law, the total enthalpy change during a direct route will be equal to the sum of the enthalpy changes during all these small steps. This can be mathematically written just like this, or another second definition of Hess's law states that the total enthalpy change for a cyclic process is equal to 0. For example, if this reactant has to be converted into product D, and if we follow the indirect route, A change into B change into C, and C change into D, and if we have to complete its cycle, the D will change into back A. So during this process, the total enthalpy change evolved or absorbed will definitely be neutralized, and for a cyclic reaction, the total enthalpy change will become 0. This is the definition of Hess's law and application of Hess's law representation. Now, the application of Hess's law are so many. With the help of Hess's law, we can draw so many enthalpy cycles. Now, the first one is the determination of enthalpy of reaction from enthalpy of reaction from enthalpy change of formation. Now, to draw the enthalpy cycle for this enthalpy change of reaction for enthalpy change of combustion, first of all we have to write down the balanced chemical equation which is given. For example, this is our balanced chemical equation for the displacement reaction of the thermite process. Say, now it will becomes Al2O3 plus 2 iron will be produced. Now this is the balanced chemical reaction. This is first step. Then we have to write down the elements in their standard states at the bottom. For example, we are taking 2 aluminium, then we are taking 2 iron, 2 mole of iron, and then we are taking 1 whole 1 by 2 of O2 gas moles. Now these are the elements. Now these elements can produce the products directly, or these elements can produce a reactant first and then the reactant change into the product. Now this is our direct route that might be considered as delta H1. Now this is the indirect route. Then this side delta enthalpy change may be considered as H2, and this is enthalpy change of reaction. Enthalpy change of reaction. Now if we want to calculate enthalpy change of reaction according to the Hess's law, enthalpy change during a direct route is equal to the enthalpy change sum of the enthalpy change of the indirect route. For example, according to the Hess's law, the formula will become delta H1 is equal to delta H2 plus delta HR. If we want to calculate delta HR, what we have to do? We have to subtract minus delta H2 from delta H1 from the direct route. Ultimately, we will get delta HR. This will be the formula used for the determination of enthalpy change of reaction from enthalpy change of formation. This is also important. Now, look at this same example. If we have the formula of formation of Fe2O3, definitely we will write down the delta H naught F of Fe2O3 here, and the enthalpy change of formation of an element is always considered equal to 0. That's why the enthalpy change of formation of Fe2O3 will be written here, and enthalpy change of formation of Al2O3 will be written here. Automatically, from this value, because this is a direct route, from this value, the value of indirect enthalpy route will be subtracted, and automatically we will get the required answer. And that enthalpy change will be equal to the enthalpy change of a reaction. I thank you all.